Okay, in this video we're going to talk about Unit 2 Objective 10 Plus. This is your first BC topic. So we're going to talk about the derivatives of parametric curves. If you have not watched the video on what is a parametric curve that was linked on the website, go ahead and watch that first and then come back and watch this one. So if we're going to talk about the derivative of a parametric curve, let's just go back and talk about what derivatives are. So we know that the slope of the tangent line is equal to the derivative, and one notation that we can use for derivative is dy dx. Now, what that dy dx means is we're taking the derivative of y with respect to x. So if we have a parametric curve that is x equals some function of t and y equals some function of t, we know that x and y are going to be what I'm taking the derivative of, and t is the variable that I'm taking the derivative with respect to. So when I take a derivative of x with respect to t, my derivative is going to say dx dt. And when I go to take the derivative of y with respect to t, we're going to get dy dt. Now, these dx and dt, the derivatives are going to be the same as we've been taking the whole time. All the rules apply, nothing's different. The only problem is we want the derivative of the entire parametric function, not two pieces. So remember, a derivative is dy over a dx. We're going to end up with dx dt and dy dt. So in order to get where we want to go, we're going to say dy over dt, so the derivative of the y part of our parametric curve, divided by dx dt, the x part of our parametric curve. So if we think about what we're seeing here, we have a fraction divided by a fraction. So when we have a fraction divided by a fraction, we multiply by the reciprocal of the denominator. So we're going to get dy dt times dt dx. Your dt's are going to cancel, and you're left with just dy dx. So in order to find the derivative dy dx of a parametrically defined function, we take the derivative of the x component, we take the derivative of the y component, and we say the derivative of the y divided by the derivative of the x component. Now, it's going to be a little bit different for our second derivative than what you would just imagine. So if we think about where we currently stand, we have a dy dx. Now, we know that the second derivative can be written d squared y over dx squared. But our function is defined in terms of t, not in terms of x. So when we take the derivative of this first derivative, we are really looking at the derivative of dy dx in terms of, or with respect to, t. So we need to kind of mess around with this in order to get that dx squared in the bottom. So the way that we're going to handle this is we're going to say the derivative of dy dx with respect to t over the derivative of x with respect to t. So what that's going to do is this here is going to give us a d squared y over dx dt. So we've taken the second derivative of y with respect to x once and with respect to t another time. but we're dividing by dx dt, so really we're multiplying by dt over dx. Our dt's will cancel. We have dx times dx, so we're going to get d squared y over dx squared. So we'll look at an example where we have to take a second derivative, see what it looks like, because the good news is we already know what this is. We have to find that in order to come up with our dy dx, so it's not a whole lot of extra work. We just have to divide by that derivative of the x component. So let's look at an example. Let's say we have the parametric curve defined by x equals t squared minus 5 and y equals 2 sine of t. And we want d squared y over dx squared. So the first derivative, all we have to do is take the derivative of the x component, so dx dt, so that would just be 2t. We have to take the derivative of the y component, dy dt, so that's going to be 2 cosine of t. And in order to get our dy dx, we have to say dy dt divided by dx dt. So we get 2 cosine t over t, over 2t, which is just cosine of t over t. So there's our first derivative. Our second derivative is the derivative of what we just found divided by the derivative of the x component. So to find the derivative of what we just found, we need quotient rule. So the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So that right there is d squared y dx dt. So we need to divide that by dx dt, but we already found that dx dt is 2t. So all we have to do is divide by 2t and simplify. So we're going to get negative t sine of t minus cosine of t in our numerator. Then if you think about this, 2t is 2t over 1. We have a fraction divided by a fraction. Multiplied by your reciprocals, we're going to get 2t to the third power for our second derivative. So we'll call it quits on the video there. We'll see you in the next one.